Hi guys, today's notes are on 2.5c. We're going to continue on with trig functions with radians, but we're going to make them a little bit more complex today. So just a quick review. Sine is y over r, and if the unit circle is what we're using, then r equals 1, which makes sine just y, right? So this is x over r, just x. Tangent is y over x, and cosecant, secant, and cotangent are the reciprocal functions, okay, not inverses. Reciprocal functions, which means that this is r over y, which is just 1 over y, right? Or you can think of it as like 1 over sine, because the s and the c go together. This one will be 1 over cosine. So this will be r over x, or just 1 over x. Please remember that 1 over y and 1 over the x don't necessarily mean there's going to be a triple fraction. This means the reciprocal of y and reciprocal of x. Okay. Cotangent is 1 over tangent, and this will be x over y. So just a quick review. Remember that when we see a 6 in the denominator, our reference angle is going to be 30. 4 in the denominator, our reference angle of the triangle should be 45. 3 translates to 60 degrees, and a 2 is 90. Okay, so as we're drawing out our triangles, we're going to be keeping track of, are these the correct reference angles? Okay, so we know that if it's over 6, we're going to have a reference angle of 30, so we're going to count by 30s. Or you can think of it as there are 6 pieces that we need to divide into. Okay, so I'm going to say divide into 6 on top. And it's only on top because this top is pi, right? So we need pi divided by 6 pieces. Well, I only have one of them. So the one that I want is this one. It has to be a special right triangle, so this is 30, or pi over 6. And since we're doing sine, we want y, which is this one. So I like to mark it on my diagram, and then I know that that value is 1/2. Okay, so this is what we did last class, right? So let's just do another check. Cosine of 2/3. Dividing into 3 is a little trickier because students oftentimes want to draw that y-axis, or they count the y-axis. This is 1 pi over 3, right? This is 2 pi over 3. So the one that I want, let's count, this is 1, this is 2. So this is the one I want. And we need to make sure that we have a reference angle of 60 degrees here. Okay, because of the 3 in the denominator. Check it. Cosine is x, and that is negative because it's going to the left. So negative 1/2. Okay, you try the next two. See if you can get them. Pause your video, or if you're still having trouble, stay with me and we'll keep drawing. Okay, we're dividing into 3 pieces, so those are 60. Notice I made my lines a little steeper. Okay, here's my y-axis in case you're wondering. So this is 3 pieces on top. There's 1 piece here, 2 pieces, 3 pieces, don't forget to count that one, 4 pieces, and 5 pieces. So the triangle I'm looking at has a reference angle of 60 degrees. And we know that sine is y, so it's going to be this one, which is negative because it's going down, √3 over 2. Remember that I'm getting my values of 1/2 versus √3 over 2 because our special right triangles are either 1/2 or √3 over 2, right? If it's a 45, 45, 90, and these are congruent, then it's √2 over 2 and √2 over 2. Okay, let's do another one. This one's divided into 6 pieces. 1, 2, 3, 4, 5, 6, and 7. So 1, 2, 3, 4, 5, 6, 7. Just to help you visualize where I'm counting here. That means this is a triangle I want. Tangent is y over x. Maybe I should write that over here. This is y. This was x. This was y. We'll do y over x. My y value is negative 1/2. My x value is negative root 3, over 2. We know that the denominators of 2 can cancel out. And the negatives cancel out, so it'll be 1 over root 3. Please rationalize your denominator, so it'll be root 3 over 3. Okay, so what we're doing today is we're making it a little bit more complicated because we're adding the reciprocal functions now. So now we're still going to draw the picture of pi over 2. Oh, sorry, 2 pi over 3, apologies. So those are my steep tons. There's 1, here's 2. So 2 pi over 3 is this. Cosecant, let's write that in. Cosecant is 1 over sine theta, which is 1 over y. So I'm going to take my y value, which is root 3 over 2, but I'm going to take the reciprocal of it, so it'll be 2 over root 3. Since we're going up, it's positive. We're going to rationalize that, so it'll be 2 root 3 over 3. What we did was multiply by root 3 on top and bottom. Okay, so let's do our first one where we divide by 4. I don't know why I avoid these. So I'm dividing by 4 on top, 4 equal pieces. And I need the third piece. So here's 1, here's 2, here's 3. So here's the triangle I want. Make sure that's a very clear 45, 45, 90. Secant is 1 over cosine, which is 1 over x. My x value is here, and it's going to be negative root 2 over 2. So I will make it a negative 2 over root 2. And when I rationalize this, it becomes just negative root 2. I'll do one more, and then the rest of them I want you guys to try on your own. If you're able to do this on your own right now, please feel free to pause my video and stop. Okay, so let's see. Cotangent, drawing this is not the hard part, right? So, however, if you're having trouble drawing it, then the rest of the problem becomes impossible. So, notice that I divided into 3 pieces on top, and I continued because I need 4 pieces now. That numerator tells us how many pieces you need. I have a reference angle of 60 because the denominator is a 3, so you can check it. Right? So then cotangent is x over y. Okay, so my x value is negative 1/2. My y value is negative root 3 over 2. And I've done this problem already. I don't know if you realize that, but that's the same as this one, right? It just happens to be the exact same one. So it's tangent, but it's just flipped. So I'm just going to skip. Here's my work. This will be root 3 over 3. Okay, so I'm going to pause the video here. You please try 8, 9, 10, 11, and 12. I will unpause and then unpause the video to check your answer. Okay, take a look and check your answers. The ones that I had the most questions on in class were these two, because we're counting by pieces that are cut in 2, right? So here's pi, so I cut the top in half. So it's every 90 degrees, 1, 2, 3. Cosecant is 1 over sine, which is 1 over y. So our y value here is -1, which reduces to -1. What else? The 2 pi was a weird one for people. If there's no denominator, that means we're just not dividing any pieces on top or any pieces on the bottom, right? So we're just going all the way to 1 pi. 2 pi shows up here. Let me know if you have any questions, but I'm going to move on to the back now. The back looks more complicated because now we have a more complex expression. So it says evaluate the expression, leaving the answer in simple radical form. Show every substitution. Use exact values from the unit circle, but try to not look at your unit circle. No calculators. Okay. So what we're going to do is we're going to draw a mini visualized triangle for each of our angles or angle measures. Okay. And then all we have to do is know our fraction rules and radical rules in order to simplify our answer at that point. So I'm going to draw 5/6 or 5 pi over 6. Divide it into 6 pieces. So we have our number 5 is over here. 1, 2, 3, 4, 5. Sine is our y value. So we know that our first value is 1/2. Then we're going to add 3, and then we're going to multiply by whatever value sine of 3/2 is. Okay, so that 3 in front just means multiplication. It's not a big deal. So I'm going to draw pi over 3 pi over 2. So pi over 2 means divided in half. So I have 1 pi over 2, 2 pi over 2, 3 pi over 2. That's down here. Sine is my y value again. So I'm going to label that as y, which is -1. So what this is saying is that I have 1/2 minus 3. Well, in order to subtract fractions, we want to make our denominators the same. So we need to multiply by 2 over 2 for common denominators. Okay, so that becomes 1/2 minus 6 over 2. You can do a check. Does 6 over 2 divide to -3? Yes. Okay. So that'll give us -5 over 2. You guys can practice the next one if you want. Okay, so it's the same thing. If you want to listen to me walk you through it, I'll walk you through this one as well. Okay. So at this point, if you're able to do it yourself, let's see, here are the answers we got in class. 4√3 over 3. I think this one was negative. Ooh, I can't remember this one. I know this one is 19 over 12. And I can't remember this one, but I'll show you in just a second. Okay, so we're going to draw, let's see, divide into 3 pieces. But there's going to be 5 of them. So I'm going to go 1, 2, 3, 4, 5. It's this triangle down here. Cosecant is 1 over sine, which is 1 over y. So I'm not actually going to simplify or rationalize my denominator. So y right now is -√3 over 2. So I'm going to write it as 3 parentheses -2 over √3. Okay. And then I'm going to have subtract 2 for tangent, and I'll have to figure out tangent of 7 pi over 6. 6, and then 7 will be the next one. Tangent is y over x. So that'll be, let's see, a bigger fraction. -1/2, -√3 over 2. Let's see, we can cancel these out. So this equals to -2 times 1 over √3 and 3. So what we can do now is multiply numerator and numerator, right? So this will be, here I'll write it the same for now, just so you guys can see. Okay, so this becomes, if I multiply on top, will be -6 over √3 minus 2 over root 3. Uh-oh, did I lose a negative? Negative over a negative, it'll be positive. Why is there a negative here? Yeah, my y value should be negative. Okay, I missed that one in class. That means this answer is going to be a little bit different. I apologize. I think this will be 8. No one got me in class, but I'm pretty sure I'm right because your y value is negative here, so it has to be negative here. Yep. Okay. So then let's see. This will be negative 8 over root 3, and then we can rationalize our denominator. This one's exactly the same. We're going to have 4, and then whatever cosine pi over 6 is, plus 10. And what I'm doing right now is, since I know it's going to be like a fraction, I'm just putting the 4 a little higher and the 10 a little higher. Cosine of pi over 6 will be this first one. That's x for cosine. So that'll be root 3 over 2. And then this one will be, let's see, 1, 2, 3, 4, 5. Sine is y. So this will be negative root 3 over 2. So what we can do now is simplify these two, right? 4 divided by 2 is 2. So we get 2 root 3. And then these two cancel out to become 5, but there's a negative here. So it'll be minus 5 root 3, which will be 2 minus 5, because these are like terms, will be negative 3 root 3. Last problem. This one, the only difference is that there's a squared now. This is just another way of writing cosine 4 pi over 3 squared and putting the squared on the outside. Okay. Plus cosecant, 4 pi over 3, and then putting the squared on the outside. Okay, so I'm going to have two fractions, and I'm going to square both of them. So let's see, cosine 4 over 3, that's this one. It's our x value. So that'll be negative 1/2 squared plus, cosecant is the same one because it's 4 over 3, right? So cosecant is 1 over sine, which is 1 over y. Our y is root 3 over 2 with a negative. So I'm just going to take the reciprocal of that, negative 2 over root 3. I don't need to rationalize the denominator yet, especially because we're going to square it. So since we're going to square it, there's no need. This is the same as negative 1 over 2 times negative 1 over 2. I'm okay if you did that in your head and you get 1/4. Then we're going to add. Now this one you want to be careful of. A lot of students cancel the radical with the squared, but it's really negative 2 times negative 2 over root 3 over root 3. Right, so that becomes 4 over 3. We do need to find common denominators to add quarters and thirds. So we're going to multiply by 3 and 3. And then this one we multiply by 4 and 4. So that gives us 3 over 12 plus 16 over 12, which equals 19 over 12. So please practice tonight's homework, and I want you to show your work step by step. In chapter 1, we did problems like this, and the problem was that a lot of you guys claimed to do the work in your head. I don't know if you did it, or if you got lucky, or if you checked the back of the answers, right, and wrote the answers down. It's impossible for me to know, so this kind of work is what I'm looking for on the test.